Chapter 6, Section 6A2 is function operations. So in Section 6A1, we do adding, subtracting, multiplying, and dividing, and today we'll do composition. The good news is with composition, you do not need domains, so that should be a little bit of a shortcut. If you take a look at this board, composition of functions just looks two different ways. So I want to make this really clear. You can either write it this way. This thing right there is a little open circle. Kind of looks like an O or a 0, but it's considerably smaller. And then on this side, you can also use it a whole bunch of parentheses. I do want to point out the orange side looks a little different. Yesterday we did something like this. Or it could have also looked like this. So just be careful. Something else we'll discuss a little later on, that they are not even close to the same. Also, I want to point out that composition of functions is not commutative, which means that order matters a lot. Always start with the function that's closest to the x value, wherever that one happens to be. It doesn't matter whether it's written with the little open circle or just with parentheses. So if you take a look at both of these, the x value is closest to f. So you'll start by putting that value into f first, and then you'll get whatever answer you have, and that would go back into g. So essentially, you're doing two different problems. If you take a look at number 1, they're going to give me an f function first, that's 2x plus 2, and then the g function is x squared. In letter A, they want me to do g of 2 first. So g of 2 means that I'm going to put a 2 in for x in the g function. So that says I should take it and square it. And 2 squared is 4. Then I need to take that 4 and plug it back into the f function. So f of 4 is the same as 2 times 4 plus 2. 2 times 4 is 8, plus 2 is 10. So my final output is 10. If you take a look at letter B, it's written using different notation, but it's the same idea. The first thing I want to do is f of 2. F of 2 says put the 2 in for x in the f function. So 2 times 2 plus 2 is 4 plus 2, which is 6. Then take that 6 and plug it into g. G of 6 says I take 6 and square it. My final output is 36. Number 2, I have two different functions now. 2x plus 12 is f, and g is 2 over x plus 3. Letter A, first thing I want to do is g of 5. So that means 2 over 5 plus 3. Well, 5 plus 3 is 8, so I'm doing 2 over 8, which is the same as 1/4. I need to take that 1/4 and plug it into f. So f of 1/4 means I should do 2 times it, so times 1/4, plus 12. 2 times 1/4 is 1/2, and 1/2 plus 12 is 25 over 2. You can have a fraction, you can have a decimal, you can have a mixed number, although that's probably not preferred. All right, letter B, g of -1 first. G of -1 just says instead of x, put a -1. In the denominator, -1 plus 3 is 2, and so I really have 2 over 2, which is 1. Then they want you to put that into f. Take that 1 and put it into f. So f of 1 says 2 times 1 plus 12, which is the same as 2 plus 12, which is 14. Number 3, two new functions, x squared plus 1 and x minus 2. Just be careful, I switched the color in case that matters. So in the first one, they want me to do f of -3. F of -3. Be careful with parentheses here. You need to make sure you put that -3 in parentheses, specifically in this one because you're squaring. That makes a difference in the calculator. -3 squared is 9, and 9 plus 1 is 10. Take that 10 and put it into g. G of 10 says 10 minus 2, so my final output is 8. Letter B, I'm going to do f of -2 first. F of -2 says square -2 and then add 1. -2 squared is 4, and 4 plus 1 is 5. Be careful with this one. They want you to turn it around and put it right back into f. So now I'm going to do f of 5. You'll get a different answer. That's okay. 5 squared plus 1 means 25 plus 1, which is 26. So I mentioned earlier that there is a difference when that circle is open versus closed. And if you do take a second, in this one, that's an open circle. That's composition. That would mean that I would take this x value, plug it into G, get an answer, and then plug that into F. That's entirely different than this situation right here. In that situation, I'd take the F function and multiply it by the G function. The green one doesn't require a domain and the red one does. That's a huge difference there. And typically your answers to composition are a lot prettier. So the green answer would probably be prettier than the red answer, depending on the input.